Hello, I wanted to take a few minutes to go over the Unit 7 free response question. Some of you have not submitted that yet, and you're going to have an alternate version if you have not submitted it. If you have submitted it, you can take the alternate version as a retest for it. One of the things that I noticed with a few of you is that you did work for values that were not yours, and that's not going to get you any points on this. Keep in mind that I had this question specifically in the direction set up so that you're going to get unique values. So you have to use the values that are given to you. So let me model this with you using what I have here. I'll give me a second to get this set up, and I'll get my calculator set up, and we'll get started. All right, I got this set up now. So like I said, I'm going to cut off the ability to complete this specific question for credit, but I will give an alternate question that'll be similar in the fact that there'll be different values generated for you to do. So you need to make sure you upload your own work. Now, if you have questions, please let me know. But here's how I'm gonna go over this question. So as a non-native English speaker, Sandra is convinced that people find more grammar and spelling mistakes in essays when they think the writer is a non-native English speaker. To test this, she randomly sorts an even number of volunteers into two groups of 44. Both groups are given the same paragraph to read. One group is told that the author of the paragraph is someone whose native language is not English. The other group is told nothing about the author. The subjects are asked to count the number of spelling and grammar mistakes in the paragraph. While the two groups found about the same number of real mistakes in the passage, the number of things that were incorrectly identified as mistakes was more interesting. Some numerical summaries of the data follow. So here's the information. You have the sample size for the non-native group, the mean, and the standard deviation. The same for the no info. And if you were like most people, the values for the mean for the non-native was slightly higher than the no info. So what we're trying to figure out is, hold on, let me get my pen. We're trying to figure out that the question, is there convincing evidence at the 5% level that the mean number of mistakes found will be greater when people like these volunteers are told that the author is non-native? So we want to know, we want to test to see if this mean is greater than this mean. So this is a two sample t-test. Two samples because, well, first of all, even though these are the same number in each sample, these are different groups, right? We're not comparing one treatment to another within the same person and then getting that difference. That would be a matched pair. This is a two sample t-test. We want to know, is this greater than, right? So we have to kind of first be able to identify the test. And then what I do is we want to actually, set it up. We want to crunch the numbers. So when you set up this test, you got to go through that 4-step process, right? You have to say, all right, and most of you probably might even were able to recognize this as a two sample t-test for the mean 1 minus mean 2. Notice how I just did mean 1 minus mean 2. You can label what each one is, but I just said the true difference in the mean number of mistakes found by people like these in the study between non-native author and unknown author. And I labeled them, the non-native was mean 1 and the no info was mean 2. So you can see that difference there. And I just labeled them, right? So identifying your parameter, right? Identifying your procedure, that's that P part. And then the assumptions, well, we also have to do our hypothesis, right? Our null would be that there is no difference. So the difference between the means is 0. And the alternative would be that the mean is greater than 0. The difference is greater than 0. And our assumptions, and honestly, just list them, right? They're randomly assigned. It says that right in the problem. Somewhere up here, let me scroll up. So yeah, so it says she randomly sorts an even number of volunteers into two groups. So we got that. Are they independent? We can assume that the volunteers account for less than 10% of their populations, but you got to state that. And then the number and the sample size, since these are both greater than 30, we've actually met the central limit theorem. So it's approximately normal. So we've met all the conditions, and for all of your work, you should have had this part set up. But the problem that I ran into was a lot of you just had wrong values. So you were either using different numbers or using your friend's numbers or something, but you got to use the numbers that are given to you in this problem if you want to get credit for it. So I kind of have it set up there where it's kind of blank, but what we want to see is we want to run a 2-sample t-test using technology. Well, how do you do that? All right, you gotta set up in your calculator. So let's look at my specific values. All right, let me make this a little bit smaller. We're going to go to stat. We're going to go to tests. 2-sample t-test, so it's going to be down to 4. And we're going to go over to stats because we have the numbers to input into our mean. So our first mean is 2.12. Our standard deviation is 2.04. And that sample size, in my case, is 44. And then I just repeat it with my second ones. And I want to make sure this is a greater than, because it says we want to see if that first one is bigger than 0. So we want to make that sure it's greater than. And we'll calculate it. And in this case here, I got 0.702 for my t. My p-value is 0.24. Now, most of the values for the p-value here are going to be smaller than alpha, so it's going to change how I approach the conclusion. But you want to report all this value, right? So I just kind of have it set up where, hey, I can plug and chug these numbers in here. So I'm going to do that real quick. My first mean is 2.12. That standard deviation is 2.04 and 44. The x bar 2 is 1.88. My sample deviation is 0.99 and 44. And I have all these values here right from my calculator. I got the t, which is 0.7. That's what you're going to put into question number 1, right? When it says put your t value in, I would put 0.702. And my p-value in this case would be 0.2426, and my degree of freedom 62.189 or 19. But I don't have to do any work for that, right? All that's in the calculator, 2-sample t-test. What we want to do is we want to interpret it. So based off of my numbers, my conclusion is going to be a little different than this, right? I would say since my p, well, I can actually do a little bit of a different scenario in this case because my p-value is quite large. So in my case here, I would say annotate down there. So I would say since p is 0.2426, which is greater than 0.05, we reject, or we fail to reject the null. Now, some of you will have a small p-value and you would reject the null. So I do not have convincing evidence to conclude that the mean number of mistakes found will be greater when people like these volunteers in the study are told that the author is a non-native speaker. So look at my p-value, right? It is a large p-value. I don't have significant evidence at that 5% level that this mean is greater than this mean. And so how does that going to affect my second part, right? Well, there's 2 routes for when it says what kind of based off your conclusion, which type of error could you make? All right, well, let's think about the type of errors we have, right? We have type 1 or type 2, right? Type 1 is you reject the null when it's true. Reject the null. I reject the null hypothesis, even though the null hypothesis is true. Well, I didn't reject the null hypothesis in this case, so I wouldn't be able to make a type 1 error. A type 2 error is you fail to reject when it's false. So let's go, I have it set up here for type 2 error. So in this case, since I failed to reject, because I had a very, very high p-value, then since I failed to reject HL, we could have made a type 2 error. We could have done that. Could have made a type 2 error. Oops. We fail to reject the null hypothesis when it's false. So therefore, we could have concluded that there is no difference in the mean number of mistakes found by people like these in the study when knowing if the author is non-native when it actually is greater. That would be a type 2 error. And that's just a rough explanation in context of why that is a type 2 error. Now, let me run the numbers here because most of you will not get this. Most of you will get some different values here. So let me go through this again, and I'm just gonna, submit it. Well, first of all, let's use my numbers here. If I had submitted this and then uploaded my work into question 2, if I would have put for T 0.702, and forget about putting a file in here right now. If I just submit that, you'll tell right now, you're going to tell right away that you get that point, right? I got that point because I had the right T value. So that should clue you in, hey, all right, I'm on the right track. I'm getting the right numbers. Well, let me go ahead and do this again. All right, so I'm going to get some different numbers, same scenario, different values here. Watch what happens. I'm going to go to stat, tests, 2 sample t-test. Let's put in our new data. Everything is the same. The setup is the same. It's still going to be greater than. If I calculate it, look at my t is a lot larger. I have a smaller p-value, and that's going to make my conclusion different, right? So when I go through this here, I'll have all the same setup. Everything here is the same, but going over here, what's that going to do to my p-value? Well, my p-value in this case is smaller, right? It is what, 0.0246. So I would reject the null hypothesis. You see, with all these, with the new numbers here, that is smaller, we would reject the null hypothesis. We have convincing evidence, if these were the numbers, to conclude that the mean number of mistakes found will be greater when the people, like these volunteers in the study, are told that the author is non-native. So, if I put my t value, list all this information here, and my t was, what was it again? Hold on. 2.01. And 0.02, list my degree of freedom, 52.2. All of that's going to depend on the numbers, right? And then these numbers here will be the numbers that you see over here. But that's going to change my information here because I rejected the null. So since I rejected the null, I could have made a type 1 error, which is when you reject the null when it's actually true. So therefore, we could have concluded that the mean number of mistakes found would be greater when knowing if the author is non-native, when it really is not greater. So then when the null is true, we remember, if we conclude the null is, if we've rejected the null, but we should have said, oh, we failed to reject the null, that means we haven't produced evidence that there is a difference, right? So we haven't produced evidence that it's greater than the other. That would be a type 1 error in this case when I rejected it, but we actually should have not. Hope that's helpful. Again, try the new free response question, whether you did it or didn't do it, and see if you can figure out what tests to run, use the numbers that are given to you, and by all means, please ask me if you have any questions on it. I'd rather you get help from me than copy a neighbor's numbers that are not yours. So good luck to you guys, and I hope that you do better.